which is 10 pi over 6, which reduces to 5 pi over 3. And I'm still good, right, because still less than 6. But I'm getting close, right? Maybe I can get one more in there. And so I've got 5 pi over 3, or 10 pi over 6, plus pi over 2, 13 pi over 6. Does that go in my list? No, because it's too big. It's bigger than 12 pi over 6. Okay. And then I come over here and I double check that over here to make sure I didn't miss any. The nice thing about this is usually you get all of them, but you do always need to double check. There's my 2 pi over 3, but it's already in the list, so I don't have to write it again, right? And then my 2 pi over 3 plus pi over 2. Didn't we do that just a minute ago? Isn't it in there? Didn't that give me that 7 pi over 6? Right? So, like I say, the nice thing about this is it normally gives you all of the ones that you need from the first answer set. But I always double check just because I'm OCD about it. I always want to make sure I got them all. Okay? So this is not a hard process. If you'll do the same process as before and you'll wait to divide out the 2, the multiple part of the angle, after you get rid of all the trig functions, and then you just add this piece on to each one until you get past. How did you get 4 pi over 3? It's a reference angle. Tangent is positive in the first quadrant and here in the third quadrant. So I have to take the pi and add pi over 3 to it to find the other angle where it's positive. Chapter 4, Section 3. Go back and look at it if you don't remember how to do that. Okay? Okay, so this one says solve sine of x over 3 equal to 1/2. And I want the solution to be between 0 and 2 pi. This is the same thing. It's the angle measurement that's got the multiple to it. But instead of it being a whole number, it's a fraction, right? X over 3 means 1/3 times x. So again, isolated, it's isolated already. I can take the arc sine of both sides. That gives me that x over 3 is equal to the arc sine of 1/2. So in other words, it's asking what angle gives me pi over 6. Is exactly right. Plus 2 pi n, right? But not only do I get pi over 6, but I also get, remember, sine is also positive in the second quadrant. So it also gives me 5 pi over 6. I always find both of them. Now what do I do to solve this for x? We're multiplying by 3. So I get x is equal to 3 pi over 6 plus 6 pi times n, right? Okay. And here I get x is equal to 15 pi over 6 plus 6 pi times n. Now, am I going to need to add anything here? If I'm adding a 6 pi, is it going to leave me in my... Okay, my restriction for my domain here is I just want the stuff that's from 0 to 2 pi, right? So I can't add 6 pi. I'll cancel the outside of it automatically, right? So I don't need that part, but always write it down because you got to double check it, okay? So my two solutions here this time are 3 pi over 6, which is pi over 2, and 15 pi over 6, which is 5 pi over 2. Okay? Didn't I? Here's my solution set. Okay, so multiple angles are not a big deal. Just the big thing that I messed up on when I used to do this is I would forget to multiply or divide this 2 pi or this 1 pi over here. It would mess me up every time. So remember that when you're getting rid of that multiple angle, multiply by all of it, not just the first one. Okay, that way you know how much to add on to find all of your pieces. Okay? Any questions? Now, we have some that we checked. Objective 3 is that we want to be able to solve these trig equations that are quadratic in form. In other words, it's got some squared stuff in there, right? So checkpoint 4. I have 2 times the sine squared of x minus 3 times the sine of x plus 1 equals 0. And we want this with the domain of x being between 0 and 2 pi. So I only want those solutions. So you got a couple of choices here. You can do a U substitution, or you can just notice that the sine and sine squared is like x and x squared. Everybody understand what I just said? If you are having a real time looking at that sign, then what you want to do is a U substitution. So you let U be equal to the middle term, to the sine of x. So then U squared is equal to the sine squared of x. Okay? Just giving it a variable so I can pull the sign out. I don't have to look at it. So that becomes 2u squared minus 3u plus 1 equals 0. Some people have a lot easier time factoring that and solving that than they do if it's got the sign still in it. Okay, so if you'll do a u substitution, it makes life a little easier for you. And now this factors into what? If we do bottoms up, we get u squared minus 3u plus 2. What two numbers multiply together to give me positive 2 that add together to give me negative 3? Negative 1 and negative 2. Right? Yes? And since I did the bottoms up and I multiplied by 2, I've got to divide the 2 back out right here before I do anything else. So I get that u minus 1/2 is equal to 0, and u minus 1 is equal to 0. If you do not know how to factor, then put it in the quadratic formula. If you don't know what I'm talking about, you better come see me during tutorials. So u is equal to a 1/2, and u is equal to 1. At this point, you now need to put the sign of x back in for u. Okay, we used the u substitution to solve it so that it was nicer and easier to look at, but that's not really u, right? What was u equal to? Sine of x. So it says the sine of x is equal to a 1/2, and the sine of x is equal to 1. No, u was actually equal to just sine to the first power of x. Okay? Now you got to use the arc sine. So x is equal to the arc sine of 1/2, which we have already said is pi over 6, right? And what else in this first period? I don't have to worry about any more, but I do have to worry about this one and this one, right? 5 pi over 6. Now I don't have to worry about any more multiples because that wasn't a multiple angle. So I can just stop right there. Now I come over here and I get x is equal to the arc sine of 1. So that's a unit circle, right? That's my y value being 1. The only place that happens is right up there. Yes? Which is pi over 2. So my solutions are pi over 6, 5 pi over 6, and pi over 2. Okay? Any questions? Okay. Objective 4 says sometimes I have to use factoring. Not necessarily a U substitution, I don't have to worry about that, but I have to factor things out like a greatest common factor idea. Okay, not a factoring into two binomials like we just did. So let's look at checkpoint 5. We have 4 times the cosine squared of x minus 3 equals 0. So there's no cosine of x, right? So if you had a quadratic equation that didn't have a cosine and a cosine squared, do you have to actually do it into two binomials? What can you do? Move everything away from the squared term and then take the square root, right? Okay. So we're going to add 3 to both sides. I've got 4 times the cosine squared of x is equal to 3. And then divide both sides by 4. So the cosine squared of x is equal to 3 over 4. Now I can't take the arc cosine until I got rid of that square, so I'm going to take the square root of both sides. So I get the cosine of x is equal to a positive and negative square root of 3 over 2. Alright, so if I have a square root of a fraction, I can square root of the top and take the square root of the bottom, and the square root of 4 is just 2. So the square root of 4 is just 2. I took the square root of the top and the square root of the bottom, and the square root of the bottom is just 2. Okay? Now I want you to notice that I want all of the cosine values that are positive and or negative. So that's going to be all of the quadrants, right? So basically, I just need to find out the reference angle from this first quadrant and then use it for all 4 quadrants. Yes? So where is the cosine equal to the square root of 3 over 2? Do I need to do it again? Can we put it back on here? Pi over 6, pi over 3, 90, 1, 2, and the square root of 3. Square root of 3 over 2, opposite for the cosine, opposite for the sine, so the adjacent side is pi over 6. So I need pi over 6, and I need the angle that has pi over 6 for a reference angle in the second quadrant, 5 pi over 6, because that's the negative square root of 3.